Hello, so this is a short video on 7.5a, which we are going to be solving exponential equations. This is getting you ready for a retake and possibly just a refresher on these topics. So I'm going to do a couple of them so you can see one of every kind. This first section, we're going to be able to look for what we call the baby bases. So I'm looking at specifically, let's look at number 1. We have a base of 3, and over here we have a base of 27. Well, I'm thinking we can rewrite this 27 as a 3. Let's call this 3 to the third power. So now my problem looks like this. 3 to the negative 3b power equals 3 to the third power. And because we have the same baby base now, you can take your exponents and you can tell me that they have to equate as well. So negative 3b has to equal a 3, and if you divide both sides by negative 3, you get b equals negative 1. So that's a neat little technique. If you notice, you have the common bases between the problem. I'm going to give you a little heads up on number 2. I think this one's a little tricky because the common base here, you might have to play with your calculator a little bit, but it's going to be a 6. So 216 is 6 to the third power, but you got to be careful because he already has an existing exponent of 3b minus 1. And actually, you know what, in hindsight, let me go ahead and look at this one with you. 36 is 6 to the second power. So this is what I'm worried about on number 2. This 3 times 3b minus 1, you have to distribute that. So that exponent is really going to become a 9b minus a 3 when you distribute the 3. And then it's going to equal this exponent of 2. Okay, so that was probably the trickiest one in that particular section. So I'm glad we got a chance to peek at that one. You finish it. This next section, we no longer have a common base. So we're going to have to deal with working with logarithms. And you're going to use your buttons on your calculator. So either the common log button or the natural log button. And oftentimes it doesn't matter which logarithm you use, but you know, I have a favorite. So let's take a look at, first of all, number 5. The exponential piece of this equation is not isolated yet, so I'm going to start by dividing this negative 4 to the other side of the equation. So now it says 8 to the power of b equals, I believe that's a 16. I don't want to get that wrong because I'm going to break out my calculator just in case. One moment. Getting my trusty calculator out. Yeah, 16. Alright, so this equals 16. And you know what, in hindsight, I think we could probably do some base work here, but let's pretend we didn't notice that. I'm going to apply a logarithm, and because the base here is an 8, natural log or common log, neither one's going to make a difference. So you guys seem to like the common log better, even though you know I like the natural log better. The reason we applied the logarithm to both sides of the equation is because now the exponent can come down in front. So this is down in front. It says b times, and then we've got the common log of 8, and it equals the common log of 16. So the common log of 8 and the common log of 16 are just really gross numbers on our calculator. So if I'm trying to solve for b, I'm going to divide the common log of 8 over to the other side. So I'm going to divide by the common log of 8, and if you use the natural log, you have the same work, just you're using a ratio of natural logs instead. Okay, these are canceling, and then this one you type on your calculator. So I'm going to steal my calculator here. We got log. Make sure you close the parenthesis after the 16. My kids forget that. All right, and this does come out to 1.3 repeating. You can just write 1. Oh, it says 10,000th. Oh boy. So that's 10 hundredths, thousandths, 10,000ths is what the answer is. Or if you recognize that that was the same thing as 4/3 as a fraction. That one particular came out to a fraction because it did have a common base, but doesn't matter. You can go ahead and round on this worksheet. So just watch out for those questions. There's a little bit of isolation. Actually, let's look at number 10. I think it's probably the hardest one. Here, the exponential piece is not isolated yet. I'm going to start by adding a 3 over. Glad I have a calculator next to me because I'm going to need it in a minute. So we have 2.6 times e to the 4 minus 2k power, and then equals 72. So we're still not isolated. The e, this is the base that has to be isolated before we worry about logarithms. So I have to divide this 2.6 over to the other side of the equation. So left side, pretty, e to the 4 minus 2x. That's not too bad. Right side, I'm going to need a calculator for. So 72 divided by 2.6 Ew, already it's gross. So it's approximately 27.6923. 1. I don't know how far I'm rounding, but for now I'm going to round to there. So now I'm going to apply, this time I'm going to choose the natural log, because if I apply the natural log to the left side of this equation, the natural log and the e will cancel, which makes for easy math for me. So the 4.2k is going to drop down, and then this is just something that I need to type on my calculator. So I'm going to do natural log of the answer that I just got in my calculator, and it's going to come out to approximately 3.32115. And then final step here is divide both sides by 4.2. So the nice thing about working with these nicer calculators that have memory is that you can just keep using the answer from your previous step. You don't have to keep retyping things. So this comes out to 0.79 tens, hundreds, thousandths. I forgot what I'm rounding to. I'm just going to round to that because I forgot what I'm doing. Alright, so there's some examples of what's on your remediation. Practice all these up and lots of work on this worksheet. The answer key is on the back. Good luck, everybody, and I hope you do well on your retake.